In propositional logic, we treat each statement as a single unit, either true or false. For example, if we say P is all men are mortal and Q is Socrates is a man, but propositional logic cannot formally show why Socrates is mortal follows from these two statements. Why? Because propositional logic cannot describe individual objects, their properties, their relationships. To express statements involving objects and properties, we need predicate logic. Today we will understand what predicates are, what quantifiers are, how to translate English into logical form, and how to negate quantified statements correctly. A predicate is a statement containing variables that becomes a proposition when values are assigned to the variables. Consider this. X is greater than 3. This statement does not have a truth value yet, because we do not know the value of x. Let us denote P of x means x greater than 3. Now we can say P of 5 is true and P of 2 is false. Once a value replaces x, the statement becomes a proposition. P of x itself is not a proposition until x is assigned a value or bound by a quantifier. And it is true for predicates with multiple variables as well. Consider R of x, y, z means x plus y equals to z. Here, the domains are integers, and we can evaluate these. The third one, R of x, 3, z, it is not a proposition. Why? Because variables x and z are still free. A statement must have all variables assigned or quantified to have a truth value. Logical operators from propositional logic still apply. Let P of x is greater than 0. So we can evaluate this. However, P of x intersect P of y. This is still not a proposition because x and y are free variables. To make it a proposition, we need quantifiers. Quantifiers tell us how many elements in the domain satisfy a predicate. There are three important quantifiers: Universal Quantifier, Existential Quantifier, and Uniqueness Quantifier. Among them, first two are most important. This is read as for all x, P of x. Meaning P of x is true for every element in the domain. For example, is this statement true? Or is for all x P of x true? No, because negative integers still exist. If the domain is positive integers, then it is true. The truth value of quantified statement depends on the domain. This is read as there exists an x such that P of x, meaning at least one element in the domain satisfies P of x. And there could be more elements as well. For example, let's P of x means x is even. Here, domains are integers. It is true because 2 exists and also 4 exists, and these are even numbers. So existential requires only one example and universal requires all elements. This means there exists exactly one x such that P of x is true. Let's say x plus 1 equals to 0. Only x equals to minus 1 satisfies this. So it is true. But if we say P of x is greater than 0, there are many solutions. So this is false. Furthermore, often we restrict the domain inside the statement. For example, the square of every negative real number is positive. This is the logical form. Notice that we use implication, not conjunction. This is a common mistake. That would claim every real number is negative and positive after squaring, which is incorrect. So the rule is universal statements in English usually translate using implication. Next, we'll understand binding and free variables. When a variable is controlled by a quantifier, it is called bound. For example, there exists an x for x plus y equals to 1. X is bound and y is free. If a variable is free, the expression is not a proposition. Only fully bound expressions have truth values. Quantified statements have some negation rules as well. If we say the original statement is every student has taken Java, its negation is there exists a student who has not taken Java. Notice that the quantifier changes and the predicate is negated. This helps in translating English to a logic. For example, every student in the class has taken Java. Let's say S of x means x is a student in this class, and g of x means x has taken Java. Here all the people are domain. The correct translation is this. And this is incorrect, because this incorrect version says everyone in the world is a student and has taken Java. This is not what the sentence means. So in short, we can say a predicate becomes a proposition when variables are assigned or quantified. And universal quantifier means true only if all elements satisfy the predicate. And existential quantifier means true if at least one element satisfies it. Finally, unique quantifier is exactly one element satisfies it. And also remember, universal English statements usually translate using implication.